Hi everybody, this is video lecture number 4, chapter 14, Mixtures and Solutions. We have one concept left. It's not mathematical, so it's a conceptual look at colligative properties. The physical properties of a solution differ from those of a pure solvent used to make the solution. All we're saying is that water has different properties than sugar water. Water has different properties than salt water. The differences are due to the number of particles in the solution rather than the specific identity of the solute. So the more you put in, the more the effect. The more sugar you put in water, the more the specific effect. The specific effect we're going to look at is boiling point elevation and freezing point depression. The addition of a non-volatile, and all that means is that the solute doesn't evaporate, will raise the boiling point and lower the freezing point of a pure solvent. So if you add salt to water, you will raise the water's boiling point. If you add salt to water, you will lower the freezing point of the water. Antifreeze lowers the freezing point of water so that cars can operate in the wintertime. But we could also call it anti-boil because it raises the temperature at which water boils. What it does is it extends the temperature or the range that a liquid stays a liquid. And the more you put in, the more the effect. If you put salt in water, it will boil at a higher temperature. So if you want to cook pasta faster, put salt in the water because water won't boil at 100 degrees anymore. Maybe it'll boil at 102 degrees. The hotter temperature will cook the food faster. The more particles there are, the more the effect. If you put CH3OH, which is methanol, which is an alcohol, in water, the methanol will not dissociate. It does not break up in the water. So if you have 1 mole of methanol, you will get 1 mole of particles. If you put salt in water, the salt will break apart or dissociate into sodium ions and chloride ions. In other words, even though a sodium ion is smaller and a chloride ion is smaller than a whole put together sodium chloride, you now have twice as many particles in solution. Twice the particles will have twice the effect on the solution. So salt water will boil at a higher temperature than water with alcohol in it. So let's get a little crazy. Calcium chloride is a solid salt. It will break apart into calcium ions, which we should know are +2 charge, or we can look it up, and 2 chloride ions, for a total of 3 moles of particles. So calcium chloride has more of an effect than sodium chloride. And if we want to go really crazy, we'll do sodium phosphate. Sodium phosphate will break up into 3 sodium ions dissolved in water and a phosphate ion. So sodium phosphate will break up into more particles than anything else. It will raise the boiling point of water higher in a solution, and it will lower the freezing point of water to a lower temperature than the other things in this list. So in summary, a colligative property depends on how many particles are in the solution. The more particles you have, the greater the effect in both directions. It raises the boiling point and it lowers the freezing point, which is why we put salt on roads in the wintertime. We want to lower the freezing point of the water and ice. So instead of water freezing at 0 degrees Celsius, now maybe it won't freeze until minus 10 degrees Celsius. Don't forget to watch the other video. Have a great weekend, and we will see you on Monday.